In this question, we're having a look at implicit differentiation. In all these questions, guys, you're always going to get some chain rule and some product rule. So please be familiar with how to do this process, and we'll have a look at this question to firm up your understanding. We've got the relation 3xy minus 9y squared plus 3 equals 0. In part A, we have to find an expression for dy dx in terms of x and y, and in part B we have to find the exact value of dy dx when y equals 1. Let's have a go at this. Part A. Now, by implicit differentiation, guys, this is what you will get. First of all, we've got here, now this is product rule, 3xy, we'll just do the xy inside the bracket. We've got, as I say, left d right plus right d left. That is the left term times the derivative of the right, which is x times the derivative of the right term with respect to x, that's dy dx, plus the right term, y, times the derivative of the left term, which is going to be just 1. Okay, so left d right plus right d left, there's your product rule, guys. Now here comes the chain rule here, 9 times. Now, please have a look at this. We've got y squared. So what it is, it's chain rule. It's the derivative of y squared with respect to y times the derivative of y with respect to x. Here's the link in your chain here, and you can see that is the same as the derivative of y squared with respect to x, okay? And then this term here gets you a nothing, and of course you've got nothing on the right hand side of the equation. So we've successfully navigated ourselves through the jungle of the product rule and the chain rule, and we've just got to simplify this now in the next line, alright? So what that gets us is 3 times x times dy dx, yes, plus 3y. Now, this one here, the derivative of y squared with respect to y is just 2y. Just the same as the derivative of a squared with respect to a would be 2a, or theta squared with respect to theta would be 2 theta, and so on. Yes, guys? So you get 9 times 2y dy dx equals 0. Now, this is great because now all we've got to do now is factorise the dy dx term out. So 3x dy dx plus 3y minus 18y dy dx equals 0. Take dy dx out. We get dy dx into 3x minus 18y equals minus 3y over the other side. Okay, now we're going to divide both sides by this term here and clean it up a little bit, and we're laughing. Dy dx equals minus 3y over 3 into x minus 6y. We can cancel the 3's and we can rearrange it a little bit so there's no minus up the top there, and we get that. Very nice. Y over 6y minus x. Alright, that's part A done and dusted. What about B now? Alright, so first of all we better find out what x is when y equals 1. When y equals 1, we plug into this equation up here, and what do we get? We get 3x times 1 minus 9 times 1 squared plus 3 equals 0, and we just work away with that, and we get 3x equals 9 minus 3, which is 6, therefore x equals 2. Jolly good show. Now we know that x is 2 and y is 1, and we can plug that into here to get our specific value of dy dx when y is 1. And there it is. So it's 1 over 6 times 1 minus 2, which is 1 over 4, and that's our answer. Yes, so please get comfortable with implicit differentiation. It's always in the exam, and it's really easy marks if you know what to do. You'll always get some product rule and chain rule, so be prepared for it. Okay?